Hi everyone, welcome to this video. This video is going to be me reviewing my time studying astronomy with the University of Central Lancashire, or UCLan for short. So UCLan offer a distance learning BSc in astronomy. So unlike the Open University, you cannot just enroll onto the Bachelor of Science straight away unless you have recent A-levels in maths and physics. I think they are say recent as being 2 years, but I think if, for example, you attained them 3 years ago, if you talk to the course leader, they'll probably be quite flexible on that. But for people like me, however, who do not have recent A-levels or any A-levels in maths or physics, what you have to do is enroll onto their level 1 modules as separate certificates. So they offer 4 of their level 1 modules or first year modules as separate certificates. There is the astronomy one, there is a cosmology one, astrobiology, and there's one called Earth, Sun and Climate, I believe. So all of their modules are 20 credits each. And what they want you to do is to at least do 2 of those individual certificates, they call them. Once you've done 2 of those, you can then enroll onto the Certificate of Higher Education. Once you've attained that, then you can either enroll onto the Diploma of Higher Education or the full BSc. So what I did the previous year, what I've just done, is the 20 credit module, an introduction to astronomy, which they offer as an individual certificate of astronomy. So first things first, what made me decide to go with the Open University this year now and complete the Master of Physics? One, you get a Master of Physics at the end and not just a BSc. But secondly, the way the modules work out at UCLan, because they're 20 credits each, you could try and do 3 of those a year and complete it in the 6 years part-time. However, when it comes to level 2, there's a couple of the level 2 or year 2 modules which have prerequisite modules, which means you have to complete one of the modules before doing the second one. The problem lies in 2 of them. Yeah, it's 2 of them. So the modules only run every other year, apart from 2 modules. So the astronomy module and the cosmology module in level 1 run every year. And also the dissertation module, I believe, runs every year. But other than that, all the other modules run every other year. So I worked out, for example, I could have done cosmology and astrobiology from this October or September. And then the year after, I could have completed level 1 and got the Certificate of Higher Education. But the year after that, the module, so there's, I think it's the Milky Way and there's Beyond the Milky Way. You have to complete the Milky Way before completing Beyond the Milky Way. However, that year, when I'd finished level 1, the Milky Way wasn't running and it was Beyond the Milky Way, but I wouldn't have been able to complete that. So that year, I'd have only been able to do the 2 modules remaining that were running that year for level 2. That meant that the year after I could have done 3 modules, but the year after that, I'd then have to go back and do the year 2 module Beyond the Milky Way. So I worked out it'd probably take me another 7 or 8 years to complete the whole Bachelor of Science, whereas the Open University, the way that's worked with the Master of Physics, I can complete the whole Master of Physics in 8 years. So that kind of swayed me to go with the Open University. Another reason that I chose the Open University is because I've already studied with them. I know how they work. I haven't done a maths or physics module with them. However, so for the Master of Physics, I'm doing the advanced start. The first modules being physics in space, which looks like it's kind of not an introductory level as sorts to physics in space, but it's kind of bridging that gap between maybe GCSE and university study physics, which for me is going to be quite beneficial. But the main thing is the maths module. So the second module I'm doing this year at the OU is Essential Maths 1, MST 124. And to me, that is going to be quite beneficial. I'm not great at maths, so I never was at school. I got a C, so I was okay, but I wasn't brilliant. And I did find doing this astronomy course with UCLan, certain parts were fairly difficult for me, and that was mainly due to the maths part. They do state that you don't really need any background knowledge in physics or maths to do the introduction to astronomy or the certificate in astronomy as it is. However, they just say you should be at GCSE level for science and maths. And maybe that's where I fell down, because I did get C's in both science and maths, but that was over 20 years ago. So there was some of the maths. They do try and explain most of it as you're going along, but there were some bits that would just throw an equation there. And I noticed a couple of times they didn't even state the units that were involved in the equation, or they didn't state certain bits that would help someone like me understand it. Other people on the course found it fine. You know, they were quite into maths and physics beforehand. Whereas I've always had a love of space and astrophysics. I've never really been into it at an academic level, shall we say. So I struggled with that. So I know the OU, doing the essential maths one, is probably going to help me gain confidence and, you know, the relevant knowledge I need to progress into the Master of Physics, or even just any undergraduate sort of level physics maths modules. So that was another reason that steered me towards the OU. Nothing against the UCLan course, because I have really enjoyed it. It's been really interesting, really in depth. What drew me to the UCLan course, first of all, before the OU introduced the Master of Physics, was the fact that it delved straight into the material. So your first module is astronomy, you've got cosmology at level 1, astrobiology, whereas the BSc in astronomy and planetary science with the OU, your first 60 credit module is the S111 questions in science, which is such a broad module in all aspects of science. You know, you study a bit of astronomy there, but there's a bit of physics, there's a bit of biology, chemistry, geology. And to be honest, that didn't really appeal to me. I wanted to get straight into the subject. So now with the OU and the Master of Physics, you can do the advanced start. So you don't have to do questions in science. You can go straight into doing Essential Maths 1 and Physics in Space. And then for your other level 1 modules, you can use the level 2 Astronomy and Planetary Science modules to fill the gap. Anyway, enough about the OU. I've done a video about that. So the UCLan, the Introduction to Astronomy module, which is the certificate in astronomy. There is a set text. They recommend getting this. So it's the Universe book. It's a big old book by Geller et al. Very thick, very big. Unfortunately, they don't offer this as part of the course, and they don't offer an online version as well. I believe I read somewhere it was too expensive to try and get the rights to offer it as a free version for students. So what they've done, there is another book, online book, you can download from the UCAN online library, which is the OpenStax Astronomy book. And the good thing about the course notes is at the beginning of each module or unit, they'll say, you know, before you read this unit, read either chapter blah blah in the Universe book or chapter so-and-so in the OpenStax book. Because the OpenStax one was free, I downloaded that as well, and I read both chapters. So I read the chapter in Universe, then I would read the chapter in OpenStax. For me, I love this book. It's massive, but I think it's going to come in handy, not just for this course I've just done, but for my further study with the Open University. It's just full of information, really interesting. So if you do love astronomy, astrophysics, or anything to do with space science, I'd recommend it. It's pricey, so if you can't, it's not a problem. Like if you do the astronomy course at UCLan, because you've got the OpenStax version book, which is free, and for the purposes of the course is just as good. But for me, this, you know, this is some sort of Bible. I'd recommend it. I think it was about, what did I pay? £63, £64. So if you can, I mean, you'll use it for the rest of your academic journey, I'd imagine, and if not, beyond that. But the OpenStax book is okay. I found the Universe one was more in depth. So there was bits in it where you'd have examples and bits to do practice questions and give you the answers, where the OpenStax book is just kind of explanatory. It gives you, kind of goes into a bit of detail about a subject, not so many questions and answers and all that. So the assessments with UCLan. So it looks like I've gone through a few of the modules like descriptions, and it looks like they mostly follow the same path. So there's 2 question sheets and either a report or some sort of essay. For the astronomy course, what we did was an experimental report. So there was a question sheet that was due sort of, is it December time or is it January? Around then. And then the experimental report, that was due sort of a couple of months after that in March. And then the second question sheet, which was due sort of May, beginning of May, around that time. So the question sheets, they are, for the astronomy course anyway, they may be the same for the other modules. There's 10 multiple choice questions, and then there's 6 or 7 more in-depth questions after that. The multiple choice questions, you don't have to show you're working out, you just select the correct answer. Sounds easy, right? No. So it's not just a case of they give you a question and they give you a couple of false answers and one is correct, and you can kind of work out which one's correct straight away from looking. They tend to give you a set of facts and they give you different answers around those facts. I've got an example. I'm not going to give you the exact figures because I don't want, just in case they use them again. So for example, on the first question sheet, it gave you the absolute magnitude of a star and the apparent magnitude of a star. And then it says, from the Earth, which of the following is true? And then it's the distance modulus is blank. And then it's the star is approximately blank parsecs from the Earth. Another option was the light from the star takes blank years to reach the Earth. Or if the star was twice as far away from Earth, it would appear 0.5 mag fainter. So what I found is that you did have to work out the answers to each of those to make sure the option was false. You couldn't just pick one and be like, oh yeah, work that out. I mean, if you picked one and it turned out to be true straight away, you could probably go with that. But I like to work out the others as well, just to make sure they were definitely false. So a lot of the multiple choice questions, probably spent the same amount of time doing the multiple choice as I did the other questions, even though for the second lot of questions, like the longer questions, you have to show you're working out. So yeah, it was a lot of information, and that's just an example of one of the questions on one of the question sheets for the multiple choice. An example on the longer bits, so this is from question sheet 1 as well, and it gives you, well, there's 3 parts of the question, and it gives you the type of the star. So in this example, it's a K-type. Types are like spectral classes. They go from O to something like M. And there's a way of working out. What's the way of working it? They give you this rhyme. You know those old school rhymes, like the planets was, I can't remember. But this one, what is it? O be a fine guy, kiss me. So O B A F G K M. And they go from brightest to not as bright. So for example, the sun is a G-type star, G2V, and then the numbers represent other things, and then you've got the V, which is like the luminosity, I believe. So anyway, the question gives you the type, K-type, gives you the temperature and a circular orbit, and it asks you to calculate the angular size of a star from an exoplanet going around the star, given the radius of the star. Also, another part of the question, given the luminosity, and it's asking you to calculate the flux from a certain point. I mean, don't get me wrong, they released the question sheet at the beginning before you've even started studying. And I looked at it and I was like, I'm never going to get this. But as you go through the course materials, you do actually, you get more confident with it. I like these sort of questions as well, because they're not always necessarily a case of it's a basic equation, bang, that's the answer. You kind of have to work it out. So you have to work another equation out to give you an answer, to then use that answer to use in another equation. And it gets your brain thinking. You're like, well, what do I have to work out to get the bits I need for this equation? So I did quite enjoy that. So they are the assessments. That was the question sheets anyway. The second assessment was the experimental report. I quite enjoyed that, but I was rubbish at it. Well, it wasn't rubbish. I got 75%, which is still really good. But in the question sheets, for example, I got 87 and 85. It gave us some data from, was it the SN? I can't remember. It gave us some data from a data set of 3 star clusters, and then we had to manipulate the data. It giving you data that had already been compensated for the extinction due to the Earth's atmosphere, but it wasn't compensated for the extinction in the universe, so like the dust and gas between us and the star cluster. And it told you, like, it gave you the equation how to work that out, but then you had to do it for all the stars in that cluster, and then formulate your own HR diagram, and then you kind of estimate an age of the star clusters. Then from that you could guess a sort of latest age of the universe. It was really interesting. I fell down slightly. There was a bit where it asked you to do the errors on each bit of data. There was kind of a bit of information how to do that. I kind of got it a bit wrong and messed that up a little bit. But for the part of getting the you know, the extinction corrected data, did my own HR diagrams. That was pretty good. I was pretty good at that considering I used Excel for ages, and really interesting, like completely different to a law essay. Really enjoyed it. So in terms of the modules, there's 12, well, I say modules, units, I call them units because otherwise I get confused with the modules. Anyway, so there's 12 units in the module Introduction to Astronomy, or the Certificate of Astronomy, whatever you want to call it. The first module is the celestial sphere, and that, to be honest, is probably one of the most simplest parts of astronomy, but it threw my mind, like how you measure where a star is on the sky. Also stuff like parallax. Parallax was all right, actually, to be fair. I kind of didn't mind that. I kind of got that quite easily. That's how far away a certain point is, and you've got the radius between yourself and the sun, and then the parallax angle, and a parsec, and that's how that's defined. The bit that really got me was this sidereal day. Like, it took me forever to get my head around it. Like, I get, like, it's because the Earth spins 23 hours, 56 minutes, but to make a full rotation where it's facing the sun again, because we've moved along, it needs to go around an extra 4 minutes, or what, I don't know. It blew my mind. And there's they do exercises, and one is to observe the night sky and to work out the sidereal day from just looking at the sky. I had to Google so many different things to find, because it wasn't really that clear in the course notes for me personally. But there's a bit in the sky where you can imagine a fake sort of hour hand, and it's between two constellations of stars, and that's where it's between those two constellations of stars. That means it's like sidereal day midnight or whatever. Or anyway, as it moves along with those stars, that will give you the time of the day as how it looks on the sky. So confusing. I probably need to look up more on that going forward with the OU, but I'm not doing the astronomy module till next year. But anyway, the second unit is the stellar magnitude scale. I kind of enjoyed that more. That was more about working out absolute magnitudes from the luminosity, and using distance modulus equations, sort of using absolute and apparent magnitudes to find distance of stars. Really enjoyed that unit, really interesting, and I kind of understood it, and yeah, that was fun. Third unit, radiation. So the nature of light, black body radiation, photometry as well. And the exercise for that bit was the length of a sidereal day. That's a bit I got confused. It kind of, these exercises on the side, you don't have to do them. They're not part of the course, but they kind of encourage you to do them because it gives you a bit more understanding. And that's where it's like you work out the length of a sidereal day yourself by picking a point in the sky and then going back a few days, weeks later and seeing how it's moved and so forth. Unit 4 was the HR diagram, the Hertzsprung-Russell diagram. That's how you map, well, that's how astronomers map stars. A useful tool that they use. The main sequence kind of goes like that, and any other stars, you've got stars top right, which are like supergiants, bottom left, like white dwarfs. So you've got the colour or temperature on the bottom, and it's kind of in a descending order as well. So you've got the hottest over here on the right hand side of the diagram. That's probably you there for you. And on the other axis going up, you can use like absolute magnitude or luminosity. So that was interesting, a bit confusing at first, but reading the textbook helped kind of get it into my head what it was about. The fifth unit, spectroscopy, spectral lines, and a bit of the Bohr theory hydrogen. That was a bit confusing at first, but really quite interesting. There was a bit on telescopes. Unit 7 was about binary star orbits and introducing Kepler's laws of motion. Unit 7 I did not like at all. There was a lot of maths in there, and for me, not a lot of explanation. So I had to do some additional looking at maths books, Googling stuff, and yeah, I found it quite confusing. Interesting, but confusing. Unit 8 was about stellar structure. I've got my folder here because I've so many bits to go over. So Unit 8, so yeah, it's equations of stellar structure, stuff I've written down here, continuity of mass, hydrostatic equilibrium, thermal equilibrium. I mean, you read this stuff when you haven't studied it and you're just like, what? Even now, like I look over the notes, I'm like, oh yeah, that's what that means. So that was Unit 8. What do we have at Unit 9? Stellar lifetimes and energy sources. What have I written there? So different energy, obviously you're going over the main energy of a star is created by nuclear energy. You go through all of that and the nuclear processes. That was Unit 9. Unit 10, stellar evolution. That was introducing the HR diagrams for clusters, which was kind of tied in with the assignment, the second assignment, the experimental report. Protostars, main sequence, red giant. So basically going through the lifetime of a star from the beginning, how it forms, its main sequence, and then how stars can end depending on what type of star they were to begin with. You've obviously got sort of neutron stars, white dwarfs, black holes, etc. Unit 11, galaxies. So we looked at the Milky Way in that one first. It looked at the distance ladder, and then looked at external galaxies as well. And then Unit 12 was also a bit of a relativity and cosmology. These were only brief introductions because obviously there's more as you go further into the Certificate of Higher Education or the BSc, whatever you decide to do. Obviously you've got a whole unit or module on cosmology, and I do believe they bring relativity in at another point as well. But relativity touched on length contraction and time dilation, and then cosmology kind of introduced the expanding universe and the Big Bang Theory. So that's an overview of the course itself. I didn't want to go into too much detail just in case you are going to study it. It was really interesting. I probably, if the OU didn't introduce the Master of Physics, I'd probably continue with the BSc with UCLan. I forgot to mention tutorials. Compared to the OU, much better. So the UCLan use Microsoft Teams. So not only can you hear the tutor and your classmates, you can actually see them. If obviously you don't want to be seen or heard, you don't have to be. But the tutor is there, you can see them, interact with them. And not only are they going through the course materials, they've got, you know, other Excel sheets or diagrams or whatever to show you. It's really interactive. The course tutor for the astronomy course, I had Dr. Megan Argo, really good, really interesting, knowledgeable, helpful as well. Like you send an email, you get an answer straight back if it's like on a working day. So much better than the OU tutorials. Like OU, I don't know what they use, I haven't been to one all year, but they use that old sort of like where you can't see the tutor. What is it run on? I can't remember. But anyway, and they're not as frequent, sometimes don't happen. Whereas these ones, like clockwork, every 2 weeks on Microsoft Teams. And the good thing as well, like the OU, some of the OU ones, they're recorded as well. So if you can't go to a tutorial, literally straight after it's finished, it's up there on Teams so you can rewatch the whole thing. So yeah, I would say that if you're not looking at doing a full degree, or if you just want to pick a few of the modules, so I say the astronomy, cosmology, astrobiology ones, they offer as standalone certificates. So if you just wanted to do one of those for fun, you know, by all means, have a look at them. I think there's a separate website called Study Astronomy, which is the website for the distance learning part of UCLan's course. And you can look at all the modules on offer there. It's, yeah, it is really interesting. As I said, if OU didn't offer the Master of Physics this year, I'd probably stayed with UCLan. But the fact is the OU, now you've got the Advanced Start Master of Physics, you can get rid of questions in science, go straight into physics space and do astronomy, planetary science, as well as the physics level 2 module. And that was the main thing for me. I think I saw a video, I think it was from the OU actually, and they said like that module, I think S217, physics from classical to quantum. They said that's kind of like a toolbox, a physicist toolbox of everything that you may need to learn and to know is all contained in that module. And even though I wanted to study astronomy and astrophysics, I kind of wanted to do that module, which isn't part of the BSc astronomy and planetary science with the OU. It's just in the physics degree. But I didn't want to do a physics degree, but I wanted to do that module. So now with the Master of Physics, you can now do both. So that is pretty much the only reason. If you are interested, please do look at UCLan. Like, to be fair, it's not much in it. It is a really good course. I highly recommend it. It's just your personal circumstance, what you want out of it at the end. Do you want a BSc? Do you just want a couple of modules? Are you happy just a BSc in astronomy? Or, you know, it's going to be down to personal choice at the end. I really enjoyed the module. Anyway, that's the video. I've probably babbled on too much already. It's probably been, what, 25 minutes. That's what I thought of the astronomy course with UCLan. Probably won't be a video for a little while. Probably next one will be my results from the OU for my law degree in a couple of months. So what are we now? Beginning of June. So that'll be in the middle of July, 19th of July, I think they come out. And then after that, I'll probably do an introduction to my modules that I'll be doing from October. So the essential maths and the physics and space. The essential maths, you can already access the first 2 units. And I think that's because they're kind of revisory units. So there's an algebra is unit 1 and graphs is unit 2, and they're kind of making sure you've got that base knowledge to then go forward with the rest of the module. So I have already started looking at those, but I'll go into more detail when the books arrive. That'll probably be about August or so. Hope you enjoyed the video, and yeah, I'll see you again next time.